You have positive charge, and you have the electrons here in a cloud around the positive nucleus. If I bring a glass rod, positively charged nearby, then these electrons, which are stuck to the atoms, they cannot freely move like in conductors, however, will spend a little bit more time on the side where the glass rod is, because they feel attracted by the glass rod, whereas the nuclei, if anything, want to go away from the glass rod. So what you're going to see is that, in a way, if I started off with a spherical atom, let's suppose this were a spherical atom or a spherical molecule, then what will happen is that you get sort of a shape like this, and the electrons spend a little bit more time here than they spend here, and that means that I have actually polarized that atom. If the electrons spend more time on this side of the atom than on this side, I have also created the phenomenon of induction, and I therefore expect that this side becomes more negative than that side. And I can show you that in a nice way with a transparency, whereby I have plus and minus signs, and I have equal number of plus and minus signs. So they represent neutral atoms. There you see them. Boy, it's a little dirty, but maybe see I can clean it a little. Okay. Okay. So here we go. So notice there are equal amount of pluses and minuses. So think of the plus and the minuses as one neutral atom, just a representation. Now I'm holding a glass rod on this side, which is positively charged. And so each atom, the electrons want to go a little bit to this side, and so the nucleus stays behind. And if each atom does that, this is what's going to happen. And now notice what you end up with. In the middle of the substance, plus and minuses cancel each other out again. But on the right side, you have created a negatively charged layer, and on the left side, you have created a positively charged layer. And so in a way, you have again induction. So even in the non-conducting objects, this side will turn negative, and this side will turn positive, and therefore, if I approach a non-conducting balloon with a glass rod, I will also see the balloon come to me. And so I can easily show you that. It doesn't make any difference whether I choose glass or whether I choose rubber. I can do it with both. Non-conducting balloons always have a potential problem. The potential problem is that they can be charged by themselves, just like the metal balloons can be charged by themselves. However, if I touch the metal balloon, then any charges there will immediately flow through me to the earth. We will understand that later, because this is a conductor. Remember, the electric fluid is conducted by a metal, but not by a non-conductor. So with this, it's more difficult. Even if I kiss it and touch it, it's not clear that I can take all the charge off. In fact, by doing that, I may even make it worse. Let's hope that it is not charged too much, and let's approach it with this glass rod and see whether I can convince you that indeed it's coming to the rod. Not because of the free electrons, but because of that process. Oh boy, huh. And it should also do the same with rubber, I hope. Now, if it were negatively charged, it may go away. It does go away, so it is negatively charged. You see that? By touching it, I actually probably charged it, and there's not much I can do about it. It's very difficult to get charge off. I already had a suspicion when I approached it with the glass. It was too eager to come to the glass. Still negatively charged. That's the way it goes. It's not because the demonstration fails, but it's because the balloon is charged and doesn't want to give it up, because it's a it is a non-conductor. Friction can cause electric charge. And that's exactly what happened when I touched this balloon and try to discharge it through friction. I may actually have charged it. If I take these party balloons that all of you may have seen, and you just rub them on your shirt, on your trousers, they stick to my hand. They have charge on them, whether it's positive or negative, I don't know, I don't even remember, it's not important. And so when I bring them to my hand is not a good conductor. But you get induction, this phenomenon that we just discussed. And so the two attract each other. The positive and the negative side attract each other. And you can stick them on the ceiling, or you can stick them on the board. You can decorate your room that way.